In this video, we solve an integration problem that requires us to perform partial fraction decomposition. The question is as follows. Integrate negative 19 x squared plus 50x minus 25 divided by x squared factor to 3x minus 5 dx. Okay, so first we need to simplify the integral, and in doing so we need to perform the partial fraction decomposition. So writing the integral as a over x plus b over x squared plus c over 3x minus 5 and call that this equation star. Why do we divide by a over x plus b over x squared? Because we have x squared in the integral on the denominator, so we have to take into account every possible term of in x up to the multiplicity, which is 2. So first, to do this easily, we multiply both sides by x squared. And then when you multiply both sides by x squared and replace x with 0 in the resulting equation, everything on the right-hand side will become 0 except b. So that helps us get b. So in multiplying, we get axb plus b plus cx squared divided by this. If x is 0, we see that ax is 0 and this part is also 0. And here we get negative 25 divided by 5 because every other term on top and bottom is 0. And so b, solving for this, we get b equals 5. And we do the same thing for c. For c now, we need to get c, we need to get rid of its denominator. So multiply everybody in equation star by 3x plus minus 5. And then set x equal, replace x with 3x, we replace x with 5 over 3, because if you set 3x minus 5 equals 0, it means that you solve, you get x equal 5 over 3. So once we do that, we multiply both sides by 3x plus 5 minus 5. So if x is 5 over 3, this term is 0, that term is 0, and this one becomes just something simple, and we simplify everything, we get c equals 2. Now use x equal 1, 2. This same the technique we use to get b and c, we cannot use it to get a, because if you multiply by x, then we still have x on the denominator for the term where the numerator is b, so there's not necessary to do that. So plug in any other value and solve for a, you will obtain a. So we, as said here, use x equal 1. And we could do any other value, let's say negative 1, except 0. So because if you use 0, then you get a divided by 0. You don't want that. So we replace x with 1 in the equation. This is what we obtain. And simplifying, we get 6 over negative 2 equals a plus b plus c over negative 2. And that leads us to a equals negative 7. So that means the integrand is now negative 7 over x plus 5 over x squared plus 2 over 3x minus 5. And so integrating the expression on the left here, the rational expression, is the same as integrating this. And that's exactly why we did the partial fraction decomposition. And I wrote here to make sure you check that this works. And if you multiply both sides, you reduce the right-hand side to the common denominator, which is x squared factor to 3x minus 5, you get exactly the same numerator. I actually did that. So now this integral, that the given integral down, it becomes negative 7 integral of 1 over x dx plus 5 integral of 1 over x squared dx and plus 2 integral of 1 over 3x minus 5. And these are basic integrals that we all know of. The integral of 1 over x is ln of x. The integral of 1 over x squared is negative 1 over x, because the derivative of 1 over x is negative 1 over x squared. And the integral of 1 over 3x minus 5 is ln of 3x minus 5, and that's then you divide the result by 3, because if you take the derivative of ln of 3x minus 5, you get 3 over 1, or you get 1 over 3x minus 5 times 3. But That's always divided by 3. And then the constant term. And this is the n.